Good morning everyone. Today we will discuss semiconductor diode. Now semiconductor diode is made of two type of material, p-type and n-type. Between these two material there is a junction, and in this junction a region is formed which is called depletion region. Now p-type and n-type, these are basically semiconductors made of acceptor type and donor type of material. Now the next figure B, shows the symbol of p-n junction diode. The positive side is called anode and the negative side is called cathode. Now you may see that how the semiconductor diode looks like. Now in here the third figure shows the semiconductor diode. In here there is, in one side we have a silver strip. That side represents the cathode or negative side, and the other side is positive or anode side. Now here we will see the construction of p-n junction diode and the depletion region. In p side we have holes and in n side we have electrons. The positively charged donor ions are represented by encircled plus signs, and negatively charged acceptor ions are similarly shown by encircled minus signs. Because of density gradient across the junction, electrons will initially diffuse through the junction to the left and holes to the right. In this process, the electrons and the holes combine with each other. As a result, acceptor ions near the junction in the p side and donor ions near the junction in the n side are left unneutralized. The unneutralized ions in the vicinity of the junction are termed uncovered charges. The positive and negative uncovered charges generate an electric field across the junction directed from n side to p side. This area is called the depletion region. Now p-n junction is connected in two types, forward biased and reverse biased. This figure shows the forward biased p-n junction diode. In here, p-type material is connected with the positive terminal of the battery and n-type material is connected with the negative terminal of the battery. The forward bias voltage V is supplied by the battery. This voltage exerts a force on the holes of the p side and on the electrons of the n side of the junction, driving them towards the junction. That is, the flow of holes from p side to n side and the flow of electrons from n side to p side increase. Since electrons and holes are oppositely charged, both these flows cause a current from p side to n side across the junction. The forward bias, however, does not affect the minority carrier current that flows in the direction opposite to the direction of majority carrier current. This is due to the fact that minority carrier current is determined by the temperature only. Now what about reverse bias junction diode? In this case, the connection is just opposite. In case of reverse bias, the p side is connected with the negative terminal of the battery and n side is connected with the positive terminal of the battery. In here, electrons and holes in the respective regions move away from the junction, thus enhancing the depletion region width. That's why in case of reverse bias for junction diode, forward current is 0 or a very negligible value. But in this case, there is a very small current which flows due to the flow of minority charge carriers, which is called the reverse saturation current. This current is dependent on the temperature. Now this shows the characteristics of p-n junction diode. The right hand side portion shows the forward bias characteristics and left hand side portion shows the reverse bias characteristics. In case of forward biased, we see initially when forward bias voltage is 0 or very low, the current is almost 0 or negligible. After some time, we see that the current increases very sharply. And at the particular voltage, forward bias voltage, after which the current increases very sharply, that voltage is called cut-in voltage. Now we see the reverse bias characteristics. In here we know that there is no forward current or very minimum forward current. So initially when we starting from 0, we increase the reverse bias voltage, the current is very minimum, and after some time there is a sharp increase of current. This current flows due to the breakdown of the junction and the particular voltage after which the breakdown occurs and we get a large amount of current, that voltage is called the reverse breakdown voltage. So characteristics of diodes is done, and the next portion we will discuss later. Thank you.